All right, guys, this is a tutorial on the esters lab. So basically you have an unknown alcohol and you're going to make an ester, an acetate ester out of it. So here's acetic acid, and in an acid catalyzed medium you're going to replace this OR group with this OH group and you're going to get an ester. So let me give you a big hint, which is that of the C4 and C5 alcohols, I really just simplified it to 3 possible C4 alcohols. You had either 1-butanol, which looks like this, N-butanol, or 2-butanol, which is also called sec-butanol, or 2-methyl-1-propanol, which is isobutanol. Okay, so these are 3 different, structurally different alcohols, so they're going to affect the structure of your ester. So let's just start by writing an example of one of these esters, and then you're going to see how we apply that to the NMR. So let's just take N-butanol as an example. I'm going to write out the ester of if I used N-butanol as my alcohol. And notice that when you look at the chemical shifts in the NMR, in the proton NMR, so all of your alcohols are going to be based on this acetate group. So that this part is not going to help you too much. But all of you should see a 2 to 3 ppm singlet peak. That corresponds to the alpha hydrogens of a carbonyl group. So that part you'll all see, okay? So that doesn't help you distinguish between these 3. But what will help you distinguish is looking at the R group, so looking at this chain, okay, that the OH group is attached to. Now, we know that hydrogens on a carbon next to an oxygen, halogen, or nitrogen push it downfield toward about 3 to 4 ppm. So these hydrogens I would expect between 3 to 4 ppm. Now you're going to have all these peaks from 1 to 2, and then you're going to have some unique things going on here. That's the part you need to focus on, is between 3 and 4, because it's going to be different for all these 3 alcohols. For example, for N-butanol, when we have this butyl chain, we have these 2 hydrogens, and so because they have these 2 neighbors only, they're going to split into the N+1 rule, so 2 + 1. These are going to show up as a triplet. These should show up between 3 and 4 ppm. So basically what I'm saying is if you have this alcohol, you will see a triplet here between 3 and 4. So if that's you, great, you're done. But another good thing to do is to look closely, make sure it really is a triplet, not a multiplet, not a doublet, not a singlet, and go through these other examples and really make sure that you understand what is the splitting pattern you would see if it was this alcohol or if it was this alcohol. Okay, so go through those and make sure you really know that there are different patterns that would arise here, and then make sure that yours corresponds to that. All right, good luck.